As we look at this problem, in some ways it's easier than others because we've been given our base equation and we've been asked to find what rate water flows into the tank. So we're looking for dV dt. The way to find that is to differentiate this entire equation with respect to t. When we do, on the left, we get dV dt equals 1/3 pi r to the first power, because we're going to subtract 1. We're also going to multiply by that 2 times h, because we've got the product rule going here, plus the derivative of h is going to be dh dt times everything else that was essentially p, so 1/3 pi r squared. The only problem with this is, and in this first part we're also going to have a dr dt. So as we have r to the 1 power, we're going to have also a dr dt, and then times h. But as you can see, we're left with a dr dt and a dh dt, and the only thing we were given in the problem is the water level rises at a rate of 3 pi centimeters per minute. Well, that's our dh dt. So I don't have anything. This I can plug in for 3 over pi. I don't have anything to put in here. They have been giving us this picture, which is the radius is 4 and the height is 12. And that's at that particular full instant, but along the way r can be anything and h can be anything, and they're proportional. So I can set up the proportion. R goes to h as 4 goes to 12, or 4h goes to 12r, or really h is equal to 3 times r, or r is equal to h over 3. Either one of these can be used. If I differentiate with respect to time, with this first one, I will get dh dt equals 3 dr dt. And if I'd done the other one, r was equal to h over 3, differentiating, I would get dr dt equals 1/3 dh dt. And this last one is the one that's most handy, because I was given this 3 over pi as dh dt. So that means dr dt is really 1/3 times 3 over pi. Those cancel out. And so now I can substitute in for these two pieces of information. So one thing, we also had to use this equation here, r equals h over 3, to get the radius. The radius is 2, since the height is 6. And so here you have everything all plugged in. We're going to have the pi's canceling here and here, 3's canceling, and so we're going to have our dV dt equal to 2 times 6 plus 2 squared is 4, or a total of 12 plus 4. When I first did this, I forgot my 2/3 here. So we've got 2 times 2 times 6 over 3 is really 8 plus 4, or 12 centimeters cubed per minute is my rate. Now there's another way we could have done the same problem using this fact that r is equal to h over 3, we could have plugged this in for this r, coming up with a new base equation. All I've done is rewritten the base equation with h over 3 in for r. As I look at it this way, I have 1/3 pi h times h is h squared times this h is going to be h cubed, and this 3 squared is 9. So this is my volume. Now when I differentiate, I don't need to do the product rule. The 3 comes down, and I have dv dt equals 3 times 1/3 pi h squared dh dt all over this 9. These 3's cancel. Now I can plug 6 directly here. 3 over pi in for dh dt, and I'm still going to get the same 12 centimeters cubed per minute. If you see this substitution, this way is easier, but if you don't see it, you can use the product rule, but either way you're going to somehow have to use this ratio.